In this video, we're going to talk about basic probability. So the probability of an event happening is the number of ways it can happen divided by the total number of possible outcomes. So let's look at our first example. An experiment consists of tossing 3 coins. List the sample space for the outcomes of this experiment. So for our outcomes, we could have all heads. So heads, heads, heads is an option. We could have heads, heads, tails. We could have heads, tails, heads. We could have heads, tails, tails. We could have tails, tails, heads. Tails, heads, tails. That's 1, 2, 3, 4, 5, 6. So we need 2 more. We could have all tails. And let's see, we need 1 more. Heads, heads, tails. Do we have tails, heads, heads? I think that's the last one we need. Okay, so those are all the possible outcomes of our experiment. And there are 8 total outcomes. So we would want to list those if we asked for a sample space, but it's just nice to know that the total was 8. So what's the probability of all heads? So as you can see, that the only time that occurs is 1 out of 8 chances. And then we sometimes can write this as a percent if they ask us to. So that would equal 12.5%. The probability of 2 tails. So 2 tails would have been, let's see, right here is 1, 2, 3 out of 8. And then we could write that as a percent. So 3 out of 8. Let me grab my calculator. Is 37.5%. The probability of no heads. So no heads would be if we have all tails. So that's 1 out of 8 or 12.5% again. And the probability of at least 1 tail would be if we had 1 tail. So it occurs 1, 2, 3, 4, 5, 6, 7 out of 8 times. We have at least 1 tail, which is also 87.5%. So how could you use complements to find the answer to part D? So a complement, as defined up here at the top, is the probability of every outcome except or not the one you were looking for. So think of the probability of at least 1 tail. The opposite of that would be the probability of no tails, which is equal to the probability of all heads. So if you think about all heads, so no tails is the opposite. So this is our complement is what I'm saying. So let me write this a little better. So at least 1 tail is the opposite of the probability of no tails, which would be all heads. So 1 minus the probability of all heads, which only occurred 1 time out of 8. So 1 minus 1/8 would give us the 7/8 that we could find by counting them up. Let's look at another example with marbles this time. A bag contains 6 red marbles, 4 blue marbles, 2 yellow marbles, and 3 white marbles. 1 marble is drawn at random. So we would just need to list them out as 6 red, 4 blue, 2 yellow, and 3 white are our possible things we could draw out of the bag. And then he wants us to find the probability of red. So red was 6 out of, and then you have to add them up. So we have 6 plus 4 is 10, plus 2 is 12, plus 3 more was 15 total marbles. So 6 out of 15 would be the probability of drawing a red marble. And then we could reduce it by dividing by 3, which would give us 2/5, which we could also write as 0.4 or 40%. The probability of blue or white would be 4 blue plus 3 white, because we have 4 blue marbles and 3 white marbles, so that would be 7 out of 8. Or not 8, excuse me, that was our last example. 7 out of 15, which if we make it into a percentage would be 46.6666%. So let's say 46.7% if we needed to write it that way. The probability of not yellow. So think about not yellow. There's a lot of things that are not yellow, but if you take out these 2 that are yellow, then we could easily tell that there are 13 that are not yellow. So 13 out of 15 would be not yellow, which is 86.67%. So let's say 86.7%. So note that we could either count all the outcomes that are not yellow, or we could think of this as 1 minus the probability of yellow. We can do this because these 2 things are equivalent. So the 2 ideas are equal. Meaning you could literally add up red, 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 like all the reds, the blues, and the whites, which are not yellow, which are 13. Or you could just say that there are 2 that are yellow, so that means 13 automatically are not yellow. The ideas are the same. Okay, let's look at another example, this time dealing with a deck of cards. So a standard deck of cards, the probability of drawing a heart would be 13 out of 52, or 1/4 of our deck of cards are hearts, which is 25%. So whichever way they wanted you to write it, you could write it. The probability of a black card would be 26 out of 52, because half of our deck of cards is black and half is red. So 50%. The probability of a 2 or a jack. There are 4 2s and there are 4 jacks in each deck of cards. So there are 8 cards that could be a 2 or a jack. And then 8 divided by 52 gives us 15.4%. If we need to write it as a percent. And the probability of not a heart would be the probability of anything other than a heart, which is 52 minus the 13 that are a heart, which gives you 39 out of 52, or 75%. Okay, let's look at one last thing today. Odds. The odds of an event occurring are equal to the ratio of the probability of an event to the probability of its complement. So let's look at this last couple of examples here. The weather forecast says there is a 75% chance of rain for Saturday. What are the odds that it will rain on Saturday? The odds would be 75 to 25, or 3 to 1 chance if we reduce it. What does the 75% mean in this problem? It means out of the next 100 days, or let's just say out of 100 days, keep it simple, it will rain for 75 of them. That's the basic idea. So you think about it out of 100. This favorable outcome in this problem is that it rains, and we would say odds of rain are 3 to 1, just like we put in the beginning. And should you make outdoor plans for Saturday? Probably not. Depends on if you want to get wet. And then what are the odds of drawing an ace at random from a deck of cards? So the odds of drawing an ace at random are 4 to 48. Just think of, you have 4 chances to draw an ace. You have 48 chances to not draw an ace. So it's